Good day everybody. My name is Chinmay Rohekar. I have completed my BE in Mechanical Engineering and MTech in Automotive Technology. I recently completed a postgraduate diploma in Robotics and Allied Technologies from CDAC-Kolkata. This video is a portfolio for the various robots that I have developed over the last 6 months and the various skills that I have enhanced in building them. To start off with, I developed a simple parallel SCARA manipulator. The robot consists of two servo motors that are controlled through two potentiometers. It also consists of an electromagnet as the end effector, which can be switched on and off using a simple switch. The robot uses forward and inverse kinematics to calculate the x and y coordinates based on the arm angles and vice versa. These values are then displayed on the LCD screen for the user. The user can also select whether he wants to control the position using the XY coordinates or the arm angles. All the projects that I have carried out display my CAD skills and ability to develop effective electronic circuits. But additionally, the key takeaway from this project is the study of forward and inverse kinematics to accurately calculate the position of the end effector. The second project that I tackled was the development of a serial manipulator arm. The robotic arm is one of the most widely used automation tool in the industry, and hence I decided to develop and control one on my own. In this project, the position of the various links is controlled through servo motors, which are again controlled through potentiometers, just like the last project. But the new thing in this project is the wireless capabilities. I have incorporated Bluetooth control in this system as well. To do so, I developed an Android app which is able to communicate with the Arduino via a Bluetooth module, allowing for remote control of the system. Thus, the robotic arm can be controlled directly through the Bluetooth app, requiring just several sliders which have been put in the app. Via these sliders, the angles of the various servo motors can be controlled. This project highlights my Android programming skills. I have developed the entire Android application using Android Studio and programmed it using the Java programming language. The third project is similar to the second one, but has an additional feature. This project contains again a serial manipulator arm, but this time the manipulator arm is mounted on a vehicle. This makes the articulated robot mobile. The Android app, which was developed for the previous project, has been further modified to include a joystick to control the motion of the vehicle as well. The position of the arm is again controlled using the sliders, but this time the joystick is used to control the position of the entire robot itself. This project further highlights my CAD modeling skills and proficiency in the necessary mechanical calculations, circuit design, and appropriate electronic part selection. Having worked with articulated robots, I decided to work on a different type of robot this time. So I developed a 2D Cartesian robot. The Cartesian robot uses two stepper motors which are controlled through the TB6600 stepper motor drivers to move the end effectors along the two different axes. Their motion is controlled using a physical joystick. Limit switches are added in the system for homing it and to prevent any undue damage to the robot. Additionally, soft limits are added to prevent the robot from going beyond the designed range. This project introduced me to the various design calculations and considerations that must be taken into account when developing a belt-driven system. The use of open-loop stepper motors also teaches the need for maintaining a continuous check on the position of the end effector and ultimately the entire system. The next project that I worked on was the development of a quadruped robot. This was by far the most challenging of all the projects that I have worked on. As it is being controlled through Wi-Fi, an ESP32 board was used in this project. The board was programmed using MicroPython. The current developed robot is able to perform simple motions such as crouching, standing up, and sitting. Additionally, it is also able to move forward, albeit in a jerky motion. I am still working on this robot to develop a smooth walking gait for the robot. This project was a big design challenge as it needed several design considerations. The servo motors needed to be accurately calibrated to achieve the correct motion. Additionally, inverse kinematics was required to correctly position the robot legs to achieve the various robot motions. My final completed project is again an articulated robot, but this robot is unique due to the development of its controlling software. The robots which have been developed previously were all controlled manually and thus needed an operator to operate them. This robot can also be operated manually, but at the same time, I have used Python to develop a GUI-based software which can be used to program and store robot cycles. These robot cycles use point-to-point programming to inform the robot which are the points that it needs to visit in a particular robot cycle. These points, once stored inside the robot cycle, can then be used to perform the tasks repetitively. This kind of programming is used in almost all the industrial robots to perform repetitive tasks such as spot welding and spray painting. I developed this project to showcase my skills in Python programming and effective GUI development in conjunction with robotics. The next two robots that I am working on are still work in progress. The first one is a cylindrical robot. A SCARA robot offers better reach and faster operating speeds as compared to a cylindrical robot, and hence this configuration is not commonly used in the industry. Hence, I am developing this robot to better understand and study one of the lesser used robots. The last project is the development of a vision-enabled Cartesian robot. The robot uses an ESP32 CAM module to detect the color and shapes of the various workpieces and then picks up and delivers the correct workpiece as required by the user. This project is still in the beginning stages and needs a lot of work to be done. But by the completion of this project, I will have learned about image processing and communication over multiple Wi-Fi devices. These are important skills that I wish to gain within the next month. Thank you all for viewing my portfolio.